take you through the lesson like oil and water. This is an oil spill cleanup lab which guides students through the engineering design process. Students will design, create, and test prototypes to clean up an oil spill from a simulated ocean environment or from marine bird feathers. Students will be able to conduct investigations into the impacts of oil spills, record detailed observations to define their challenge, and propose and test solutions for how to solve the problem of cleaning up oil spills. This is a middle school version of the lesson, but we also have a high school version that's a bit more advanced, and at the end of this video, I'll show you how the two are a bit different. The subjects for this lesson are environmental science, earth science, and social studies. This actually has two labs that students would be doing simultaneously, but in this video we're going to take them each in turn. So let's get started. For this part of the lab, students will need 1 cup of water, 1 cup of cooking oil, and 3 natural bird feathers. My friend Carol has joined me here today to help me walk through the first lab, which is called Feathered Friends. Students are walked through the process of making and recording detailed observations about their marine feathers in a variety of different states. First, students observe a clean, dry feather. They write some observations about the feather and make a sketch of it in their data table. Next, students take the feather and dip it into the water. They then record more detailed observations about the feather. How does it behave? Does it repel water? Does it change shape once it's wet? And finally, students take the feather and dip it into the oil. They make another set of observations about the feather that's been covered in cooking oil. They look at its shape, if it's still repelling water, if it's changed at all, and what changes it's undergone. And again, students sketch their feather. After making their observations and making their final sketch of the feather in oil, students will summarize their findings by answering a few questions in their data table. They'll answer questions like, what are the qualities of a clean feather compared to an oily feather? Why do you think feathers might be important for marine birds to have, and how could it be a problem for a marine bird if their feathers are covered in oil from a spill? Students will then state their challenge, which is to restore their feather covered in oil to its original condition. Provide students with a series of different materials to help in their cleanup efforts. Things like an old toothbrush, cut up stockings, gauze pads, cotton balls, tape, and whatever else you can find that students might be able to use in a creative way. As you can see, Carol's already gotten started on the design process. Students will design, sketch, and then test 3 prototypes for cleaning the oil from their feather. In order to test each prototype, we've created a scale where they rank a feather from 1 to 5, with 1 being unhealthy and completely covered in oil, and 5 being healthy exactly how it was before it had oil on it. After each prototype test, students rate their feather on the scale, and then they record their results and consider how to improve their prototype for the next test. The second lab is called Seashore Superheroes. Each student group will need 1 plastic bin filled with water, a cup containing 100 milliliters of cooking oil, a larger empty plastic cup with a 100 milliliter mark labeled, and a drinking straw. Students start by again making some observations. They take their 100 milliliters of oil and pour it gently into their ocean. Students make some observations and record what they've seen on their data table. Next, students take a straw and gently blow on their simulated marine ecosystem to see the effect of wind on an oil spill. And finally, after making their observations and recording these in the data table, students take one hand and gently splash around in their spill to simulate waves. Students again record their observations in the data table. They then summarize their findings by answering a few questions. Is oil more or less dense than water? What is the impact of wind and waves on an oil spill? And how could even a small spill have a huge impact on an ocean ecosystem? So now students state the challenge for this lab. The goal is to get as much of the original oil spill out of the water as possible and get it into this cup. They use the same materials as their peers are using for the Feathered Friends lab, and as you can see, Carol's going to get started on experimenting with her 3 prototypes. To test each prototype, in this case, students are going to have 1 minute to get as much of the oil spill out as possible and into this cup. That's where this 100 milliliter mark is helpful, because students will be estimating the percentage of the original spill that their prototype device was able to capture. After students have designed and tested their 3 prototypes, they will come back together as a whole class for the discussion questions for both of these 2 labs. So most of the questions are about the process and the engineering design steps that students took. Why was it important for them to make observations before designing their first prototype? What was the necessity of defining the challenge? You can close by relating it back to the real world. Ask students, what was the most successful method you found for either cleaning your feather or cleaning your whole marine environment, and how could this possibly be scaled up for real-world oil spills? In the high school version of this activity, it's still using the engineering design process, but students only do 1 lab, the Seashore Superheroes version, and they do not do Feathered Friends. Instead of making observations, students do guided research and readings about real oil spill cleanup techniques. Students do make their 3 prototypes, but as high schoolers, instead of simply estimating the percentage of the spill that has been taken out by each device, students will use a graduated cylinder in order to measure exactly how much oil was taken out and then do some calculations to figure out the efficacy of each prototype. So that was Like Oil and Water. For more lessons like this one, go to our website, www.populationeducation.org. Thanks for watching.